Let me work you through, this is planes and pulleys problem number 2. And in this problem we got a 5 kilogram block of wood. It's on a 47-degree angle plane. It's 13 meters long, and they want us to find the force parallel and the force perpendicular. Right, so parallel force is just the component of gravity down the plane. That's going to be mg sine theta. Right, so it's 5 times 9.81 times sine of 47. Right, and it might come as a surprise that that's actually hold on here, 5 times 9.81 times the sine of 47. It's actually 35.87, right? Which is, about 36 newtons down the plane, but we're going to use the more accurate 35.87 newtons. And that's the part of gravity that it's always going to act down the plane. Every single problem we do, we're always going to make it negative because negative is down the plane, up the plane's positive, right? The perpendicular force, for what it's worth, is mg cos theta, right? And that's 5 times 9.81 times cos 47, right? And that equals, well, let's just try that. I'm going to go back. I'm actually going to go second entry, go back and change my sine to a cosine because I'm so lazy. All right, so that's 33.45, which is about 33, right? And these are the answers that we get for this, right? Okay, and then the acceleration, this is question A, right? Question B is, if we drop it and let it go down the plane, well, this force here, the parallel force, is the only force acting, right? So that's the force down the plane, is that 35.87, right? That's going to be negative, and so our picture of the forces is minus 35.87. That's the only force, right? And then that equals 5 times A. I'm using F equals MA, right? So here's all the forces. That equals M times A, right? And then, of course, A is going to be, let's go second entry, there it is, and divided by 5. I get 7. Since that's negative, right, I get an A is equal to negative 7.17, I'll say 175 meters per second squared, right? Okay. Now, sadly, we only have 2 sig figs, so we have to say negative 7.2 per second squared, right? Circle that, but there it is. We're going to use this guy here, though, 7.175 on the next problem, right? Which is, what time will it take to slide down the plane? Well, we can do that, right? We were told the plane is 13 meters long. If it's sliding down the plane, right, then it has to go down 13 meters, right? The initial velocity is 0. Final is we don't care. Acceleration is, well, negative 7.175. And I'm carrying a couple extra sig figs here, right? And then we want to find the time. The one to use here is S is ut plus 1/2 at squared, right? So negative 13 equals, well, the initial velocity is 0, so that goes away, right? 1/2 negative 7.175 t squared. Well, we can solve that, right? Let's do it. 2 times 13 divided by the answer I just got. I've got that 7.175 on my calculator, right? Equals that, and I'm going to raise that to the, I'm going to square root that, and I get that the time is about 1.9 seconds. Yay! Suvat works even on inclined planes, right? Let's see what D has for us. Ooh, it's accelerating up the plane, and we have some unknown force, right? Well, we know darn well it's going to be an up the plane force, right? But we always make unknown forces positive. We still have down the plane that 35.87, the mg sine theta that we figured out. That's the force parallel, right? And this guy's going to be down the plane, because down the plane is always negative, up the plane is positive. That's the way I do it. All right. So this guy's positive, unknown force is positive. The picture of our forces looks like this. Some force minus, 35.87. That was trying to be some other number there, right? Okay. That's our parallel force, right? And then that equals 5 times, and then this is up the plane, so that becomes a positive 4.5. Right? So I can do this. Let's see, hold on. 35.87 plus 5 times 4.5. 58.37. Now we have only 2 sig figs, so we have to say 58 newtons. Smiley, we got to put a little smiley face there. Yeah? And then E does this. Let's see, E is, now we're accelerating down the plane, right? Same exact problem, but we're accelerating down. That's going to make this a negative acceleration. Same two forces. We got the parallel force down the plane, that 35.87 that we got in the first part of this, right, with mg sine theta, right? Make sure you're not in radians, right? Okay, we got that. That guy's going to be down the plane. Unknown forces, well, we don't know. It's accelerating down the plane. Is the force up the plane or down the plane? We don't know. Well, Newton's law will make this clear to us, right? Okay, so let's go whoop, whoop. Unknown force minus parallel force. Right? Okay, and then that equals 5 times, and then let's see, our acceleration is down the plane, so it's negative 4.5. Same exact thing we did before, only now it's, we got a negative force because it's accelerating down the plane, right? So I'm going to go 5 times negative 4.5, and then I'm going to add 35.87. And I get 13.37. Right? That's Newton's. The fact that it's positive and it comes out positive means that it's up the plane. It's not like because it's accelerating down the plane, it's a force down the plane. No. In fact, you might wonder, well, how can there be a force up the plane and it still accelerates down the plane? Remember that when there was no force acting, right, when that force wasn't acting on it, right, that it accelerated down the plane at something like negative 7.2, right? That was its acceleration down the plane. That's what we got in the I don't know, second question or first question, right? Here it's only accelerating at 4.5, so to make it accelerate that slowly, 4.5, we actually have to arrest some of that acceleration, right? Hinder it, as it were. What is the word I am looking for? I hope that helps.